This is your flip lesson on soil. This will go into your spiral notebook as notes for this next part of the unit. The title of this flip video is called Soil Profile. It's basically taking a look, if we were to dig down into a chunk of ground outside and pull out a column of soil, what does it look like from top to bottom? Okay, so a soil profile is defined as layers of soil from the top to the bottom, so from the grass all the way down to the bottom. Each layer is called a horizon. And there are different horizons that you can see here in the different colors. The top layer is called the O horizon. We call that the litter. It's not actually like trash, all right? But it's the grass, the plants, the animals, the surface that we work on or walk on right there at the very top of a soil profile. The next layer is called the A horizon. That's the topsoil. It's the darkest layer because it contains something called humus. That's not hummus like you eat, it's humus. And humus is basically the dead stuff. Dead plants and animals that get mixed in with the soil. The darker this layer is, the more healthy the soil is. The next layer down is the B horizon. It's the subsoil. It's a reddish brown color. There are fewer nutrients, less water available, a limited plant growth. Okay, so the deeper you go. Here is where we're going to start to see roots. And as those get deeper and deeper, the amount of actual plant growth gets less. Below the B is the C horizon. This is called the parent material. All right, the parent material is what gives us our subsoil, our topsoil, and our litter. All right, it's a light gray color. There's no nutrients, no plants, no animals. There's weathered rock and sediment. Okay, so this is where big chunks of rock are starting to get broken down into smaller chunks from water. All right, and finally down at the bottom is the D horizon. We call that the bedrock. This is a solid chunk of rock or big pieces of rock that are not weathered whatsoever. This next board is a picture of a soil profile. Remember, I am not an artist. I don't expect you to be an artist as well. But if you want to see like an actual diagram, if you Google soil profile, you'll get a picture similar to this. So up here at the top where you see our grass, that's the O horizon. Just below that, that dark layer that you see would be the humus, the dead stuff. There are roots coming down through here which we find in this A horizon. Notice down here in the B horizon, we still have some chunks of rock. We don't have any plant roots. All right, very limited growth. As we go down further to the C horizon, we start to see still big chunks of rocks. This will be a reddish brown color here. This would be more gray. And then down here in level D, those are just rocks. And so this is a big chunk of soil. If we were to dig down in and pull a clump out from the horizons, this is what we would get. This picture is a soil profile. What does the soil look like from top to bottom? So how does soil get made? It all goes back to the rock cycle. Okay, so it gets made by weathered rocks. Rain, snow, wind, water, breaking those rocks down into tiny, tiny pieces. Sediments form. Sediments is soil. Okay, if you live in a warm, wet climate, soil gets made faster. If it's a warm, wet climate, that rain will beat down the rocks a lot faster than in a cool or dry climate. Okay, what is soil made of? If we were to ask, what are the ingredients? It's made up of rocks. It has air, water, and then it's made of dead plants and animals as well. Okay, what are some characteristics of soil? We're going to discuss this in class on Friday. So we first talk about the texture. What does it feel like? So it could be gritty, it could be smooth, it could be silky, it could be soft, things like that. We talk about the size of the particles. Gravel has large particles. Sand and silt, this gets smaller, and clay has the smallest particles. And particle size has everything to do with water retention, and we're going to investigate that in a lab. When we talk about the pH of the soil, what is its acid level or acidity? If you remember the 1 tomato, 2 tomato lab that we did early in the school year, when you added acid to the soil, it actually made your tomatoes grow. So acid level does play a role in what can grow there. And then water retention. How well does your soil hold water? All right, and it has everything to do with the particle size. All right, we sometimes refer to this water retention as pore space. Okay, it's the space between the particles. Gravel is not going to hold water very well because the particles are large. There's a lot of space in between them. If you pour water, it'll all come through the bottom. Whereas if I have a beaker of clay and pour water through it, no water will come through the bottom because those particle size are too small for it.